What is up, Flutter devs? Matt here, aka Super Declarative, and today I'd like to talk to you a little bit about text layout and text selection in Flutter. Let's go have a look. Here we have a selectable text widget which ships with Flutter. You'll notice that as I move the cursor over the text, we get a text icon or a text-based I-beam cursor, and I can drag to select text. I can also tap to insert a caret. Now again, this widget ships with Flutter, and on a mobile device, this widget probably does everything that you want it to do. But as you move more towards web and desktop development with Flutter, this widget is probably not going to cut it for a few different reasons. First, let's notice that even though we can place the caret in different locations, it gives us this standard blinking effect, which may or may not be what you want. Now you can control the color and the thickness and even the corner radius of this caret, but you really don't have any control over the finer details of how it renders. You're stuck with whatever you're given. Second, notice that even when I tap in the middle of a word, the caret appears either at the end or the beginning of that word. Now, this might make sense for mobile where we have our fat thumbs and we're tapping all over the place, but on web and desktop, we have a mouse, we have very precise tapping and selection. So really, this caret should appear wherever I tap, specifically within the text. Third, as I drag to select, we have this blue highlight, which is a very natural color, but last I looked, I don't think that we have control over that color. If we do, you in the comments, you can go down there and correct me, but I didn't notice any control over this color, which is something, again, that you may want to play with in a desktop or web environment. Also, when I double tap, I get the entire word that I tapped on. That's pretty normal. That's pretty typical. But in a browser, if you triple tap, you get the entire paragraph. What happens here? 1, 2, 3, triple tap actually deselects, and that may not be what you want. So the point here is that this selectable text widget, it does the typical thing you expect for a mobile device, but it doesn't necessarily do what you want it to do for a desktop or a web environment, and it does not offer the diversity of customizations that you might want for unusual projects on web and desktop. And so this is the topic that I want to peel back today and talk a little bit about. What do you do when you arrive in a situation like this? When you look at alternatives to Flutter, other toolkits that are out there, whether we're talking about traditional Android, traditional iOS, various web options, often if you run into this problem, you're just hosed. You don't have any other option because, text is one of these very low-level things. So what can you really hope to do with text? You use what you're given, and that's all that's available. The wonderful thing about Flutter is that nearly everything is highly compositional, and that even includes text. There is quite a bit that we can do with text before we get to a layer below the Dart code. So within Dart alone, Dart and Flutter, we can do a lot of stuff with text, even though the very lowest levels of text layout are handled by native libraries. So let's look at what we can do with text. We can begin with just a regular text widget. You'll notice that it doesn't look like anything has changed here, but actually we're now looking at a regular text widget. I can tap all over the place, nothing is happening. So you can see that a text widget, given the same text style, it shows you the exact same layout, right? All of this text is in the exact same place as the previous example we looked at. It just doesn't have any of the selection capabilities. And in fact, if you look at the implementation for selectable text, you'll find that there is a text widget down there in the widget tree. Here's our goal. Our goal is to take the plain non-selectable text widget and make modifications to it or additions to it until we arrive with what you see here. You'll notice that we have the cursor back, the I-beam, and in fact, we gain an ability here in this example that we didn't have before. Look at this blank space over here towards the end. Notice that the cursor looks like a regular pointer cursor, but when I intersect the text, we get the I-beam. Let's go back for just a moment to the regular selectable text widget. Notice that even when I'm over empty space, we get the I-beam. So anytime that we move over the entire rectangle for selectable text, we get the I-beam, even though we might prefer that you only see the I-beam when you're literally over text. Here back in the goal, and this is something that I've implemented, notice that we get the expected cursor behavior. Also, we can tap anywhere and place a caret within a word or at the boundary. Anywhere we tap, that's where the caret goes. The caret isn't blinking because I didn't make it blink. I'm actually drawing this caret, so I have full control over what it looks like. And we can select, and as we select, not only do we get a different selection color, but the caret is still displayed at the trailing end of the selection. So we select from left to right, and the caret's on the right. We select from right to left, the caret's on the left. And of course, this isn't just a visual effect, which is demonstrated by this text down here. As we select, we can actually compute the text that is selected, which of course is the purpose of selecting text. It's to do something with it. We can build this version of a selectable text widget starting only with a regular non-selectable text widget. We can compose non-selectable text into selectable text, which is a level of control over text that is rather unusual because, again, text is usually a very low-level detail. Now, before we get into actually implementing that goal, let's make sure we understand just a few concepts about text layout. Given a span of text on the screen, there's a concept of text position. You can ignore this affinity part. Really, we just care about the offset. We have an offset into the text. So in this case, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Offset 11 is where this caret is currently sitting. That's how we actually index into this text. We talk about a text position. Now, if we take two text positions and we give them a direction, we say which one is the start and which one is the end, that's when we get text selection. Although it's not really called start and end, it's called, as you see here, base is where the selection begins and extent is where the selection ends. Now, when we drag from left to right, the extent or the base is less than the extent. Here it's 11 and 19 respectively. But if we drag the other direction from right to left, then the base would be larger than the extent. The base is not the smaller, the extent is not the larger. The base is where we begin, the extent is where we end, and that depends on which direction you're selecting. Now, given a text selection, you might wonder how we actually know what rectangles to paint here. We're painting a yellow rectangle for selection, and we're painting a red rectangle for the caret. That brings us to the third and final concept, which are text boxes. It turns out that every text widget you have ever displayed internally has essentially invisible boxes that you're seeing here. What I did in this example is I took those boxes and I painted a border around them. But these boxes always exist. They are how the text layout system works. If you calculate an offset, essentially a subregion of one of these rectangles, and paint it yellow based on your selection, that's how we get the yellow selection rectangle. So you can kind of think of it as an intersection of selection with these rectangles, and that is the selection rectangle, and you can paint it whatever color you want. With those concepts in mind, let's come down here to build it. We have a regular text widget waiting to have the selection ability added to it, composed with it, and that's what we're going to do in the next step. Let's implement a custom selectable text widget beginning with this plain text widget. As I mentioned, it is a plain text widget. It just displays some text with a given style. That's what we're starting with. I also have a selection painter down here, and all this selection painter knows how to do is take some rectangles and either fill them or outline them with a color. That's all we're going to need from a painting perspective to do selection, text outlines, and draw a caret. Now, as I just suggested, all we really need are rectangles. So in terms of what we're painting, we're going to want a list of rectangles for for all of the text boxes. We'll just call them text boxes for lack of a better term. We're going to want a list of rectangles for the selection area. In fact, let's refer to all of these as rectangles because that's really what they are. And then we're going to want a caret rectangle. If we can paint all of those things, then we essentially have our goal of text selection. And we'll make sure that the caret rect is always non-null by starting it out with rect 0. Let's begin by figuring out how to paint these text rectangles. First of all, where do we paint them? Let's paint them in a stack. We'll place the text in a stack, and beneath the text in the stack will be a custom paint. The painter will be a selection painter, as I mentioned before. The color in this case will be gray. The rectangles will be the text rectangles, and we want to outline them so the fill will be false. Right now, this won't display anything because there are no text rectangles. It's empty. Let's figure out how we can compute these. The key to this entire thing about text layout is leveraging something that the text widget creates behind the scenes called a render paragraph. The render paragraph knows about where all the text is laid out, and that answers questions that we have about various rectangles and positions. So the important question is, how do we gain access to that render paragraph? The answer is we begin by introducing a global key that we'll just call text key. We will then pass that key to the text widget. When the text widget behind the scenes creates its render paragraph, we will be able to access that via the global key that we passed in. In fact, let's create a local getter method that makes this very easy for us. We will say get render paragraph, and we will return the text key current context find render object as render paragraph, because in this case, we know it's a render paragraph. We know that that's what a text widget creates. And now anywhere else in our state object, we can access that render paragraph very easily. Next, let's create a method that says compute recs for selection. So given some text selection, give us the rectangles that encompass or contain that selection. Right now, we're just worried about outlining all of the text. So when we call this method, we're going to select all the text. But let's see how we would solve this problem. First, if there is no render paragraph, for whatever reason, we can't ask any questions of the render paragraph, in which case we're going to return an empty list. Otherwise, we're going to say render paragraph, get boxes for selection, and we're going to pass in our text selection. Now this returns a bunch of text boxes, but text boxes are not rectangles. However, there is a very convenient way to convert these text boxes into rectangles. We can say, in this case, return text boxes.map. We'll take a box, and every box has a method called toRect, which very conveniently for us gives us a rectangle representation of that box. And then we'll convert that mapping into a list. This now allows us to compute rectangles for any selection. So if we call this and we pass in a selection that starts at 0 and goes all the way to the end of the text, that will give us the rectangles that cover all of the text. Let's say we can create a method called, let's say, update all text recs. We will now update this list right here. Again, how do we do that? We will say text recs. We will clear out whatever was already in there. And then we will add all, and we will call compute recs for selection. And then the only remaining question is, what do we pass for the text selection? Well, I just told you the base is going to be 0. That's the beginning. And we're going to go from the beginning to the end. What is the end? Well, that's the text dot length. That's the end of the available text. We call setState so that we redraw the UI when we refresh these text rectangles. Let's save that. So now we theoretically have the behavior necessary to draw those text rectangles, but we still aren't invoking this method anywhere. There's one important thing to understand when you're using global keys to access render objects. The very first time that we send this widget tree over to Flutter, there are no render objects yet. So we can't invoke methods that talk to the render paragraph inside of the build method, at least not without some additional behavior to make sure we're not calling it at the wrong time. We need to know that the widget tree has been sent over to Flutter and Flutter has at least computed one frame of UI, and then we know the render objects exist. I'm going to show you just one way to do that. There are many nuances to this, but in our case, because our text never changes in this particular case, here's what we can do. We can say init state, and we can actually schedule a callback using the widget's binding instance. We can add a post frame callback. This callback will be run after the current frame, which is after the render objects have been created. And then we can say update all text recs. Okay, let's save that. Let's do a hot restart to get our init state in there. And there we have the outlines of our text. Okay, so what we're doing here is we're saying starting at offset 0, going to the very end of the text, we tell the render paragraph, calculate all of the boxes in between. In this case, there are 3 boxes because we have 3 lines. These are the rectangles, and then we just paint them with an outline. So now we can see what we're dealing with as we do further calculations. Let's next move to the cursor. Notice that the cursor doesn't change. Let's come back to our widget tree. Let's surround the stack with a mouse region. And for the cursor, now you might be tempted to say system mouse cursors.text. And sure enough, notice the cursor is an I-beam, but it's an I-beam even when we're in empty space, because mouse region is based on the bounding box of the entire widget, not our individual text boxes. This isn't going to work. Instead, we want a cursor variable. We'll come up here, we will say mouse cursor, we will initialize it to the basic cursor. And then the question is, when and how do we change the cursor? Here's what we're going to do. We're going to wrap our mouse region with a listener. We're going to say on pointer hover. We're going to implement, we'll just call it on mouse move to be more descriptive for our case. We'll implement a local method called on mouse move, void on mouse move. We're going to get an incoming event. If that event is a pointer hover event, then, if render paragraph is null, we need to always be careful with that. We're going to do nothing. But so now we know that render paragraph isn't null. Here's what we're going to do. We're going to say render paragraph get, so on mouse move, what we want to know is, are we intersecting any of those rectangles? Any of these rectangles that we computed down here, we want to know if we're intersecting them. We calculate all those rectangles, and then we're going to say for rect in all text recs, if rectangle contains event local position, so if the mouse cursor is within one of those rectangles, then we're going to say is over text is true. At the end of this, we're going to say new cursor. So this right here calculates whether or not we are currently intersecting any text based on the text boxes. If we are over text, then the cursor that we want, system mouse cursors, is text. Otherwise, we want basic. And if the new cursor is not equal to the current cursor that we're displaying, we're going to call setState and make it the new cursor. Now let's save that. Now notice that we have the regular cursor over here in empty space, and the moment that we intersect one of these rectangles, we now have the text I-beam cursor. All right, so there is the cursor handled. Now let's deal with the caret and selection. For this, for the caret and the selection span, we need to deal with gestures. So let's create a gesture detector here. Let's say on pan start. I'm just going to declare these. We will implement them up above. Okay, now we need to go stub them out and then implement them. On pan start, we'll take in a drag start details. On pan update. On pan end. And on pan cancel. And the question is, what do we need to do in each of these? When we begin panning, we need to keep track of our starting text position, the place in the text where we begin dragging. So we can say selection base offset. And then we'll say selection base offset is equal to, and again, if, now this should never be able to occur if render paragraph is null, because you can't pan if there's no UI, but just in case, we will return. We'll say render paragraph, get position, meaning text position, for offset, and we will pass in the local position. And we will say dot offset. This is where we are beginning our selection. Let's also update, let's keep track of text selection as well. Text selection, we'll just call it text selection. We will begin with a collapsed text selection, meaning the beginning and end are at the same spot, and -1 essentially means nothing is selected. In on pan start, let's set text selection equal to text selection collapsed, the place that we just calculated. And then we would like to update selection display, which is something we haven't defined yet, but we want to update the selection rectangle and the caret. So let's implement that method. For the caret, we want to draw a rectangle at the current extent position, the trailing end of the selection. This requires both a caret offset and a caret height. The caret offset can be render paragraph, get offset for caret. What is the text position? It's the selection.extent. And for this caret prototype, just ignore this and pass in the 0 rectangle. Then the caret height is render paragraph, get full height for caret. We pass in the exact same offset. And then we can set state, and we can say caret rect equals rect from left top with height. We're going to say caret offset dx -1. Why -1? That's because I'm making the width 2. And then the top is caret offset dy, and then the height is caret height. Now let's actually ensure that we're painting the caret rect to make sure this does what we think it does. We'll come back down here to the widget tree. We'll copy the custom paint for the text boxes. We'll paste it on top of the text. This time we're going to make it blue. We're going to paint the caret rect and only the caret rect, and we're going to fill it in. Let's save that. And notice that anywhere I tap, we paint a blue rectangle, width of 2, height that is equivalent to the text box height. And now we have a caret. Now, while we're down here, let's go ahead and set up for painting these selection boxes, which is the same selection painter, except this time we're going to make them yellow. And we're going to pass in the selection recs, and we're going to fill them in. Now, that's not going to paint anything yet because we haven't calculated any selection rectangles yet. But first, let's come up to on-pan update. We need to make sure that as we drag, we do the right thing. Here, we will calculate a selection extent offset, which is equal to the render paragraph, get position for offset, details, local position, dot offset. It's the exact same thing we did up here when we started panning, except now we're not calculating the base or the beginning, we're calculating the extent, the end. Then text selection is text selection not collapsed anymore. Now it has a selection base offset, and it has a selection extent offset. And then we will update selection display. Now notice, as I drag, the caret moves because the extent is moving. Now, technically, the selection area is already being calculated. We just need to go ahead and draw it. So here in update selection display, we want to compute selection rectangles. Well, we already have the compute recs for selection. We'll just pass in our current selection, and there's our rectangles. And then down here in set state, we will say selection recs, clear, add all, and pass in the new ones that we just computed. And we're going to ignore these, the pan end and pan cancel for now. It's not particularly important. But let's come back over here and notice that all of a sudden, there's our selection. And notice we can drag from left to right, right to left. The caret is at the correct position. Both the caret and the selection are the same height as those rectangles, which is why I painted them for our benefit. And the last thing we're going to do is let's make sure that our selection really is a text selection, that we can get the text back out by updating this text down here. When we update the selection display, this is not necessarily the ideal place to do this, but we can get away with it for now. We'll say widget on selection change, which is something I've already implemented. We will say text selection. Let's see, we want the text inside of the selection, and we will apply that to the widget text. Actually, I'm sorry, it just wants us to pass in the text selection. So that should calculate it for us. Let's save that. And sure enough, our selection is actually turned into some subsection of text, which means we can do whatever we want with this selected text. And so here you have the proof that you can start with a plain text widget and you can add behavior to it to make it selectable, to paint a caret however you want, paint a selection however you want, alter the cursor when and how you want. You could just continue from here to do whatever you want with your own custom selectable text widget. So I hope you learned something in this video. I hope you're feeling better about text manipulation in Flutter, and I'll see you in the next video.